Now see, in uniform circular motion, in uniform circular motion, when the object moves in a circular path with the constant speed, then we say body is body is having uniform circular motion. It means the body is traveling or covering equal distances along the circumference in the equal intervals of time. Suppose you have taken, this is a circular path, I am taking, this is O and this is the point A. Body is moving along this circular path here in anti-clockwise direction and covering equal distances along the circumference in the equal intervals of time. We say body is moving, body is having uniform circular motion. When the body moves in uniform circular motion, but it has direction, because its velocity keeps on changing. Suppose when the body is at this point A, this is the point O, direction of radius is this is a r vector. When the body reaches to the point B, here this side, and this we write here r plus this delta r, this is here the displacement, this is here delta r. Now, when the body is at this point, velocity is in this direction, that is v1, and when the body is at this point, velocity is in that direction, that is v2. The angle at the center that is made, that is here theta. Now, we can draw this graph, these two velocities taken at a point. Suppose here you write velocity v1 to this side, v2 to this side. So, this will represent change in velocity, that is delta v. This is also here theta. But here magnitude of velocity v1 is equal to magnitude of velocity v2 is equal to v. Similarly, here this r, if you take the magnitude of this radius, that will remain same. Now, this you have written, this is angle theta, this is angle theta. This is representing change in velocity. You can write acceleration, magnitude of the acceleration is equal to change in velocity divided by time interval. But here this is A. Now, you can also write here theta is equal to delta, this is velocity divided by, here you can take v1, and also we can write here this delta r upon r magnitude, this velocity here, this can be written angle theta. Now, if you have got this theta, if you have got this here, from here you can write theta is equal to delta v, magnitude of this change in velocity is equal to theta into v, v1 is equal to v2 is equal to v, I have written, so directly v. So, A can be written theta into v divided by delta t. Now, in place of delta v, this change in velocity, I have replaced this value. V upon delta, this theta upon delta t can be written omega. So, A is equal to, can be written omega into v, and now we can write A is equal to, omega is equal to, already we know that is a v upon r into v. So, we can write A is equal to v square upon r. So, whether you write A is equal to v square upon r or you write A is equal to omega into v, all these are the acceleration of the body. This acceleration is known as centripetal acceleration. So, this A is called here centripetal acceleration. So, in uniform circular motion, I have derived acceleration, that is a centripetal acceleration. Direction of centripetal acceleration is towards the center, that is in the direction of the change in velocity. It is up to you, whatever the formula is required you can take. So, when the body moves in a circular path and the body is covering equal distances in equal interval of time along its circumference, then the body is said to have uniform circular motion, and it has a acceleration that is known as centripetal acceleration, which is directed towards the center. See, in uniform circular motion, we have done centripetal acceleration. And now we will take one more example. Suppose already we know this relation, V is equal to omega cross, this is r. And a linear velocity, that means linear velocity is the cross product of angular velocity and radius vector. If we differentiate it, we can take dv upon dt is equal to, here we can write d omega upon dt into r cross plus here omega across dr upon dt. I have differentiated by using the product rule. So, you will be getting A is equal to alpha cross r plus omega cross v. Now, this is A is equal to, this is known as tangential acceleration plus this is known as centripetal acceleration. So, when the body is moving in a circular path, it can have both acceleration, tangential as well as centripetal, like this. The body is here, this point is O, AT is to this side and AC is to this side, resultant will be somewhere here. Now, the magnitude of this acceleration can be calculated under root of this AT square plus AC square. But if uniform circular motion is there, that means angular velocity remains constant. So, for the uniform circular motion, AT will be 0. If AT is 0, then you will be getting A is equal to only that is AC. So, that means when the body is moving in a circular uniform circular motion, angular velocity remains constant and there is no tangential acceleration. And in this case, body has only centripetal acceleration. Now, say in this example, a stone tied to the end of a string 80 centimeter long is whirled in a horizontal circle with a constant speed. If the stone makes 14 revolutions in 25 seconds, what is the magnitude and direction of the acceleration of the stone? Now, see, suppose a stone is tied in a string and it is revolved like this, it is moving in a circular path like this. So, you are given here the radius of the path, that is 80 centimeters. So, you can write r is equal to 80 centimeter, that is 0.8 meter. You have got 14 revolution in 25 seconds. So, you have to find first number of revolution in 1 second. So, you can write frequency f is equal to 14 divided by 25, it is a revolution per second. So, from here you have got this new f, that is a frequency. Now, you can calculate omega is equal to 2 pi f, that is 2 into 22 by 7 into 14 by 25, that is equal to 88 divided by 25, here revolution per second. Now, in this case you have got omega. Now, you know the value of A, that is centripetal acceleration, AC is equal to, we can write V square upon R. You know the value of V is equal to omega R. So, here AC is equal to omega square divided by R, omega square into R. So, here you put all these values, 88 divided by 25 square into 0.8, and then you will be getting 9.90 meter per second square. So, this is the here acceleration, this is called centripetal acceleration and it is directed towards the center of the path. Now, say in this question, a cyclist is riding with a speed of 27 km per hour. As he approaches a circular turn on the road of a radius 80 meter, he applies brakes and reduces his speed at the constant rate of 0.5 meter per second square. what is the net acceleration, what is the magnitude and direction of the net acceleration of the cyclist on the circular turn. Now see what things are given to you. First you are given velocity is equal to 27 kilometer per hour, that you can convert into meter per second. 27 into 5 by 18 meter per second, that is equal to 7.5 meter per second. So this is velocity, r is equal to 80 meter. So first we can calculate centripetal acceleration v square upon r, that is 7.5 square divided by 80, that is equal to 0.7 meter per second square. In this question, this is given 0.5 meter per second square. This is your tangential acceleration. So we can write 80 is equal to 0.5 meter per second square. Now we can calculate total acceleration. A is equal to under root of AC square plus AT square, and this is A is equal to, by putting the AC and AT, you will be getting here 0.86 meter per second square. This is the value of A, that is net acceleration. Now see here, now we can see with the help of the diagram all these things. Suppose this body is moving in a circular path, this is O here. So AC is acting to this side, AT is acting to this side. The direction of velocity will be here, opposite to this. So the AC and AT both are at 90 degree. Their resultant is A is coming here, this A is coming to this side. Now we can calculate this angle also. This angle is, suppose we can take beta. So we can write tan beta is equal to AC upon AT, that is 0.7 divided by 0.5. The beta is equal to coming tan inverse 1.4. So this is the net acceleration. A is coming 0.86 meter per second square, angle beta is coming this. So this question actually has both tangential acceleration as well as centripetal acceleration. Now you can practice more examples related to these. Now say in this example, if both the speed of the body and radius of its circular path are doubled, what will happen to the centripetal acceleration? You know it, AC is equal to V square upon R. Now we can take new velocity, V dash is equal to 2V and R dash is equal to 2R. So new centripetal acceleration will be here twice of V square divided by twice of R, that is 4V square divided by 2R, this is cancelled 2. So AC dash will be getting 2V square upon R, that is twice of AC. So acceleration becomes double of this.